Imagine this scenario. 2030, you're 30 years old, just had a daughter. At the same time you have a twin brother, looks exactly like you, born on the exact same day, also 30 years old right now. Then you make a decision, go to space. Not to the moon, not to Mars, but to Proxima Centauri, a star 4.2 light-years from Earth, humanity's nearest neighbor. You board a spacecraft, speed 90% of light speed, 270,000 kilometers per second. You wave goodbye, your twin brother holding your newborn daughter stands at the launch site. You press the start button, the ship accelerates, rushes into space. 1 year later you reach Proxima Centauri. There you take some photos, collect samples, look at that red dwarf star, then turn around and come home. Another year, you return to Earth. Landing, hatch opens, you walk out, feels like only 2 years passed. But the scene you see makes you collapse. At the launch site, an old man sits in a wheelchair, hair completely white, face covered in wrinkles, hands trembling. You approach, he lifts his head, tears stream down. "Brother," he says, voice hoarse. You recognize him, that's your twin brother, but he's already 82 years old. You're 2 years away, Earth past 52 years. Standing beside you is a woman, 52 years old, wrinkles at the corners of her eyes. She walks over, hugs you, crying. "Dad," she says, "I waited for you my whole life." That's your daughter. 2 years ago she was a baby in your arms, now she's 22 years older than you. You're 32, she's 52. This isn't science fiction, this is physics. This isn't maybe will happen, this will definitely happen. If you truly fly at 90% light speed, this is the outcome. Brutal, irreversible, real outcome. 1905, Einstein published a paper on the electrodynamics of moving bodies, later called special relativity. Inside there's a formula, looks complex but the meaning is simple. The faster you go, the slower time passes. Not psychologically slow, not mentally slow, but physically slow. Your atomic clock runs slower, your heartbeat slows, your cell division decelerates, every chemical reaction in your body, every electron jump, every quantum process, all slowed down. This isn't an illusion, this is reality. GPS satellites are the proof. GPS satellites orbit 20,000 kilometers from Earth, speed 3.9 kilometers per second. Because of the speed, time on the satellites is slower than on Earth, 7 microseconds slower per day. Sounds tiny? But without correction, GPS positioning would drift 10 kilometers per day. So the GPS system must adjust satellite clocks forward 7 microseconds every day. This is time dilation, not theory but engineering problem. Because the universe has an iron law, the speed of light is constant. No matter how fast you go, no matter which direction, light speed is always 300,000 kilometers per second. It won't get faster just because you run fast, won't get slower just because you chase it, light speed never changes. But this creates a problem. Imagine you're on a spaceship, turn on a flashlight, light shoots out at 300,000 kilometers per second. But the ship itself is also moving at 270,000 kilometers per second, so from Earth's perspective shouldn't light speed be 300,000 plus 270 equals 570,000 kilometers per second? Wrong. From Earth's perspective light speed is still 300,000 kilometers per second. From the ship's perspective light speed is also 300,000. How is this possible? Because time slowed down. On the ship you feel light traveling at 300,000 kilometers per second, but from Earth's view your time runs slower. So your 1 second is much longer than Earth's 1 second, this way light speed can remain constant. The price is time is no longer absolute. Back to that spaceship, 90% light speed, plug into the formula, ship passes 1 year, Earth passes 2.3 years. You fly to Proxima Centauri, distance 4.2 light-years, speed 90% light, ship time about 2 years, round-trip ship passes 4 years. But Earth passes 4 times 2.3 equals 9.2 years. Wait, I just said 52 years? That's because I added acceleration and deceleration time. The ship can't instantly accelerate to 90% light speed. Assuming acceleration is twice Earth's gravity, that's 20 meters per second squared, accelerating from rest to 90% light speed takes 13.5 million seconds, that's 156 days. Deceleration also takes 156 days. Round trip for acceleration-deceleration cycles total 624 days, nearly 2 years. During these 2 years of acceleration, time dilation effect is gradual, averaging out Earth passes 7 years. Add the 9.2 years of cruising, Earth total passes 16.2 years. But that's still not 52 years. Because I lied. If you really want Earth to pass 52 years while you only pass 2, you need to fly faster, 99.9% light speed. At that point the time dilation factor is 22.4, you pass 1 year Earth passes 22.4 years, you pass 2 years Earth passes 44.8 years. Add acceleration-deceleration, Earth passes 52 years while you only age 2 years, from 30 to 32. Your daughter goes from 0 to 52, your twin brother from 30 to 82. This is the price of time. But wait, who's right? Here's a question. From the ship's view, Earth is moving. From Earth's view, the ship is moving. So why does the ship person stay young and not the Earth person? This is the twin paradox. Einstein's relativity says motion is relative. You see me moving, I see you moving, both correct. So why does time dilation only happen on the ship? The answer is because the ship accelerated. This is key. Earth always stayed in an inertial frame, no acceleration, but the ship accelerated at launch, decelerated at arrival, accelerated returning, decelerated landing, for accelerations. This breaks the symmetry. Acceleration is absolute. On the ship you can feel acceleration, pressed into your seat. People on Earth don't feel it. So the ship person truly left the inertial frame, truly experienced acceleration, truly time slowed down. This isn't symmetric. Earth is right, the ship is wrong, or rather the ship paid the price. This isn't theoretical. In 1971 physicists did an experiment. They took 2 extremely precise atomic clocks, one on the ground, one on a plane. The plane circled Earth for dozens of hours at 900 kilometers per hour. Then they compared the clocks. The plane's clock was slower by 59 nanoseconds, perfectly matching relativity's prediction. 2010, scientists repeated the experiment with more precise clocks. They put one atomic clock on a shelf 1 meter high, another on the ground. Just 1 meter height difference, different gravity, different speed, different time. The higher clock runs faster by 0.0000000000000003 seconds per second, but instruments can detect it. Time dilation isn't an illusion, it's reality. What if you go even faster? 90% light speed isn't the limit. If it's 99% light speed, time dilation factor 7.1, you pass 1 year Earth passes 7.1 years. 99.9% light speed, factor 22.4, you pass 1 year Earth passes 22.4 years. 99.99%, factor 70.7, you pass 1 year Earth passes 70.7 years. 99.999% light speed, factor 223.6, you pass 1 year Earth passes 223.6 years. 99.9999%, factor 707, you pass 1 year Earth passes 707 years. Imagine, you board a ship at 99.9999% light speed. Before departure you kiss your girlfriend goodbye, she's 20. You fly toward the galactic center, 26,000 light-years away. On the ship you only need 37 years, you return to Earth at 57. But Earth has passed 52,000 years, your girlfriend has been dead for 51,980 years. Human civilization might be extinct, might have colonized the galaxy, might have become a completely different species. You land on Earth but it's no longer your Earth. This is why light speed travel is a curse. Yes, you can go anywhere, yes, you can reach any corner of the galaxy in your lifetime, but the price is you can never return home. Not the spatial home, but the temporal home. The era you left, the people you left, the civilization you left, when you return they're all gone. This is crueler than death, because you're still alive but everyone you loved has been dead for thousands of years. 2014, the movie Interstellar had a famous scene. Protagonist Cooper lands on a planet. That planet is near a black hole. The black hole's gravity warps space-time. Time on the planet is much slower than far away. Cooper spent 3 hours on the surface, returns to the ship to find his companion waited 23 years. That companion watches 23 years of video recordings, watches his own children grow from babies, marry, have children, all in the videos. He broke down, the audience broke down, because this was too real. This isn't science fiction, this is science. Nolan hired physicist Kip Thorne, Nobel laureate, to ensure the movie's physics was correct. That black hole was computer-rendered from Einstein's equations, that time dilation was truly calculated. If such a planet existed, time would truly flow that way. In relativity's universe, time isn't free, time isn't fair, time isn't absolute, time is a resource. You can trade speed for space, fly fast enough you can reach anywhere in your lifetime. But the price you pay is other people's time. You fly to Proxima feeling you've only been gone 2 years, but on Earth your child lost their father for 52 years. You fly to the galactic center feeling only 37 years passed, but human civilization has evolved for 52,000 years. Every second you saved was stolen from someone else. This is relativity's cruelest truth. Here's another strange question. Who lives longer? The ship person or the Earth person? The answer is both and neither. Biologically, the ship person only aged 2 years, heart only beat for 2 years, cells only divided for 2 years. They lived 2 years, but from the cosmic history perspective they experienced 52 years of universe time. They existed for 52 years. So they simultaneously lived 2 years and lived 52 years, depends how you define alive. This is relativity's most mind-bending aspect, no absolute answer, only reference frames. Imagine you're 5 years old, dad goes to space, he says I'll be back soon. You wait and wait, elementary school graduation he doesn't return, middle school graduation he doesn't return. University graduation he doesn't return, you get married he doesn't return, you have children he doesn't return, your children go to school he doesn't return, your children get married he doesn't return, you retire at 65. Then one day a spaceship lands, the hatch opens, a man walks out, 35 years old, 30 years younger than you. He looks at you, tears streaming down. Child, he says, I'm sorry, I was only gone 5 years. But you've been waiting 60 years. This is the twin paradox, not a paradox but reality, brutal, irreversible, true reality. The universe isn't fair, some people can steal time with speed, some people can only age in place. Some people can fly to the future, some people forever stuck in the present. This isn't a choice, this is physical law. Einstein with one simple formula shattered our illusion about time. Time isn't a uniformly flowing river, time is warpable fabric. Speed can stretch it, gravity can compress it, and we're just ants crawling on this fabric, thinking we walk straight lines, but actually space is curving, time is dilating. Each of us is on a different timeline, just the speed differences are too small for us to feel. But if one day humans truly build near-light speed ships, then the twin paradox will no longer be a thought experiment but a real tragedy. Some will go to the stars, some will stay on Earth, those who go will stay young, those who stay will age. When they meet again they'll no longer be the same age, fathers younger than sons, brothers younger than brothers, friends become strangers, because they're walking in different times. This is relativity's price, this is the universe's truth. Time isn't shared public property, time is the universe's most expensive, most unequal, most cruel currency. And light speed is its exchange rate, the faster you fly the more your time is worth, but the less other people's time is worth. This is why when you return from space, your child might be older than you. This isn't science fiction, this is physics. This isn't the future, this is now. GPS satellites experience this every day, just the scale is too small for us to feel. But the formula is there, the truth is there, waiting for the day when humanity truly embarks on the stellar journey. Then every goodbye might be forever, not because of death, but because of time.